With lesson 23, we dwell on the properties of quadrilaterals and some special quadrilaterals. Okay? A quadrilateral is a polygon with four sides. So, how do we find its perimeter? We simply add the lengths of those four sides. Now, another really important property of a quadrilateral is that the sum of the interior angle measures is 360 degrees. The sum of the exterior angle measures for any polygon is 360 degrees. But for the quadrilateral, the sum of the interior angle measures is also 360 degrees. Now, quadrilaterals break into some special quadrilaterals. These would be parallelograms, rhombuses, trapezoids, kites, or rectangles, and squares. So these are all special types of quadrilaterals. Parallelograms are defined as quadrilaterals where opposite sides are parallel. So both pairs of opposite sides are parallel in a parallelogram. In a trapezoid, on the other hand, we only have one pair and only one pair of parallel opposite sides. In a kite, we've got two distinct, congruent, consecutive side pairs. So how do you construct a kite? You actually stick two isosceles triangles on top of each other to get a kite. But these two isosceles triangles have got to be distinct. So this pair of sides has got to be of a different length than this pair of sides. A really important property of kites is that the diagonals are perpendicular to each other. And in any situation where the diagonals are perpendicular, I can find the area of that quadrilateral by simply taking the product of the diagonal lengths and dividing by 2. Another situation where I've got the diagonals perpendicular is in the case of a rhombus. The definition of a rhombus is actually a quadrilateral with 4 congruent sides. So if your quadrilateral has all sides that are equal length, then you have a rhombus. A rectangle, on the other hand, has got 4 congruent angles, and if you've got congruent angles, that means they are right angles. So a quadrilateral with 4 right angles is called a rectangle, and a square is a regular quadrilateral. Now, what's a regular polygon? It's got all angles congruent, and it's also got all sides congruent. In a triangle, congruent angles means or implies congruent sides, but not in a quadrilateral or any polygon with a higher number of sides than 3. So in A quadrilateral, if you've got sides congruent, that means you're a rhombus. If you've got angles congruent, that means you're a rectangle. But not all rhombuses are rectangles or vice versa. So you need to define a special quadrilateral that's got both congruent sides and congruent angles. Let us briefly show that the opposite sides of a parallelogram are congruent. So we're given parallelogram ABCD. Let us simply draw a line segment or diagonal BD, okay? Now we can see that angle ABD is congruent. This would be angle ABD is congruent to angle CDB. And also angle DBC is congruent to angle ADB. This is because when a transversal cuts two parallel lines, alternate interior angles are congruent. Now, since we've got BD congruent to itself by the reflexive property, we can then conclude triangle ADB is congruent to triangle CBD by the ASA theorem, angle side angle theorem, congruence. And from that, we can conclude that AD is congruent to CB and AB is congruent to CD because corresponding parts of congruent triangles are congruent. If you take a look at the area formulas for these special types of quadrilaterals, for the parallelogram, it would simply be base times height. Okay, so the area for the parallelogram would simply be base times height. And a triangle is actually considered as half of a parallelogram. You can take a parallelogram and divide it into two congruent triangles, and hence the area formula for a triangle, base times height over 2. A rhombus, because a rhombus is also a special kind of a parallelogram, you can use the base times height formula, or because the diagonals are congruent, you can simply take the diagonal lengths, say E and F, and take the product of the diagonal lengths and divide by 2. For a rectangle, because the height is actually the length of the width, if you take the length of your base and then the width would be your height, because your angles are 90 degrees, you would simply get the area formula, which is length times width, which is in line with the parallelogram formula. And for a square, of course, because a square is a special kind of a rectangle, you can simply say the area is a side length squared. And for the kite, of course, because the kite is also a quadrilateral with perpendicular diagonals, you can simply take E times F over 2, where E and F refer to diagonal lengths. For a trapezoid, you might think of a trapezoid as making up a half of a parallelogram. So if you take this trapezoid and you flip it around and you stick it at the end, what you get is actually a parallelogram composed of two copies of our trapezoid. So the base would be A plus C, and the height would simply be H. But this is really a composition of two trapezoids. So to get the area, you'd have to divide this A plus C times H over 2. So basically, the area formula for a trapezoid would be the average of the bases, which are the parallel sides, times the height So let's do an example where we're given one of the bases to be 10 and the other base to be 16 and the area to be 30. And we're also told that this is an isosceles trapezoid. Now the isosceles trapezoid simply means that we've got the two legs, the non-parallel sides, equal to each other. So let's try to find one of these legs, the length of a leg. So what do we have? We can find H by using the area formula. So we take 10 plus 16 over 2 times H equal to 130. Now, this simplifies as 13H equal to 130. H is simply 10. So we can say, well, that's a 10. If that's another 10, and this whole thing is a 16, then this is formed as a rectangle here. So I've got 3 and a 3 at this side. I could use a Pythagorean theorem to find K, which gives me K squared equal to 10 squared plus 3 squared, or K squared equal to 109, which gives me a K value of the square root of 109. In lesson 23, we looked at quadrilaterals and their special types like parallelograms, rhombuses, rectangles, squares, trapezoids, kites. And we showed some properties of parallelograms. We proved them. And we also looked at area formulas and how we can use the properties with some of these formulas to figure out lengths or areas or other important quantities that had to do with these quadrilaterals. I hope this lesson has been useful, and I will see you in the solutions to worksheet 23.